Hi everyone, am I audible? Please confirm your chat. Today's session, we're going to start with virtualization. Let's get started. Please confirm whether you are able to see my screen. So before getting the session, would have got some news related to the lab sessions, right? So you'll be doing two lab practices before the exam, and post that you'll be doing two exercises. Okay. So deadlines will differ. Keep you informed. Login credentials will also be shared with you in a week. Then it was taken care by Sterling. Send. Also provide certain details where you can raise your queries. Post sharing the credentials. Okay. I will also try to guide you with those exercises, upcoming sessions. Like when we get into presentations like when we get into topics like IAS, get into questions, I'll also teach you what you usually. It's a simple exercise like how to create AC2 instance. I think that is the first exercise. And second is you'll be creating a static website using S3 bucket. So we'll give you a list. Even you can try it from that as well. That list also I'll share. So that we'll start with virtualization. Today we'll see virtualization in detail. What are the types of virtualization? Virtualization. And that we'll see hardware virtualization, how to manage resources with respect to SaaS, PaaS, and IaaS and others. So virtualization, we all know we're going to create virtual resource or a device. Okay. So where the framework itself divides the resources into one or more execution environments. So you could see example like you can do virtual drivers, you can have virtual memory, you can have virtual machines and virtual service. So why it is so popular, you can see from the diagram. So if you see a traditional architecture, how it differs from virtual architecture. So traditional architecture, you'll have underlying hardware. On top of that, you'll have a operating system. And above that, you'll have applications. Just limited to that operating system. Whereas in virtual architecture, you can see on top of the hardware, you don't have a operating system. For that, instead of that, you have a virtualization layer, which is the hypervisor or the virtual machine monitor. And above that, you may have multiple guest OS and its application on top of it. Let's say you may have multiple machines on top of it, like it could be a Windows machine or a Linux machine. You want to put those you want to run, you can run for the specific application you want to. So hardware-based virtualization, you can see. So hardware, you'll be having under the inside the server, and on top of that, you'll have the virtual machine management. On top of that, you'll have the guest OS and the application software. let's see what is hardware-based virtualization. You will have various logical layers with respect to OS-based virtualization. So on a VM, you will first install a operating system, and then subsequently you will generate the virtual machines. So it is like you are abstract, you are having an abstract execution environment in terms of computer hardware. Like you don't know what is running as the base hardware, and on top of that you run the guest operating system. Okay, which is called as hardware level virtualization. Means that hardware, you don't know what hardware it is running. Okay, so the guest OS will consolidate the hardware which is running under it. So here the operating system represents the guest. Okay, and the physical hardware, that is your computer hardware, represents the host. Okay, all your cloud or any private virtualization you do, it takes the same way. So here the combinational emulation represents it as a virtual machine. And your hypervisor is known as the virtual machine manager. So here the virtual machines are allowed to interact with hardware without any intermediate action. Okay, from the host operating system. So that's why it is called as hardware-based virtualization. So it can directly communicate without the interrupt or interaction of the underlying guest OS. So a fundamental component of hardware virtualization is the hypervisor, or the other name is virtual machine manager. So you can think in a simple way like, so at the bottom you will have the hardware, and you're going to virtualize the hardware. Yeah, as it is an abstract layer, any VM can access the virtualized layer. That's it. So you can see, look at this diagram. We have two kinds of hypervisor. Now you understand what is a hypervisor. So the component or the software which is used to virtualize the hardware is called as the hypervisor. Okay, or the virtual machine manager. Where it will be placed, and it has two types. One is type 1 is type 1 hypervisor. It has multiple names like full hypervisor. And similarly, a type 2 hypervisor, which is called as post what is that, para virtualization. Okay, so you'll see those types. Or software virtualization hypervisor, one is called as hardware virtualization. Okay, now you can see in the type 1 hypervisor. On top of the hardware, you have the VM, that is hypervisor. Hypervisor is directly installed on a bare metal machine. Okay. And in type 2 hypervisor, if you see on top of the hardware, you have a OS running. And on top of that, you have installed a guest OS. That is your virtual machine manager or the hypervisor. So the example, like here, you can say like it is the Oracle VirtualBox or the VMware. Okay. At the end of the session, I'll also show you what. Let's see in detail about the hypervisors. So, as I told you, these hypervisors, they run on top of the hardware, and they stand in for the operating system and directly communicates with the instruction set architecture. So ISA is the instruction set architecture interface. Usually, your operating system will interact with those components. Okay, so that through that only the underlying architecture or the hardware will be accessed. Let's say you would have studied about computer architecture. There you would have studied about instruction set architecture. For Intel, you will have certain set of architecture. Through those mnemonic codes or instruction sets only, the OS will communicate with the hardware. Okay. So above, on top of this hypervisor only, you have guest operating system. Okay, you may have multiple guest operating system, which we call it as groups. So this runs directly or natively on the hardware. So this is also called as native virtual machine. Next is your type 2 hypervisor, which is to deliver virtualization services. Type 2, it requires assistance of the OS. So how your VMs will communicate with the hardware is through an operating system which is already running on top of the your hardware. You take this laptop. This laptop is running on an Intel i3 processor, and it has some memory and it has some hard drive. Okay. So how am I communicating with the hardware is through operating system only. I'm communicating with the hardware and getting used to benefit out of it. Okay. Whereas if you take now I can also install what is that virtualization software on top of this operating system, and how my software will communicate. It communicates with the hardware through a operating system. Okay. So if you see, this means that the operating system managed applications will communicate via the API, and it simulates the ISA. Okay, like a virtual hardware for the guest operating system. How in the sense, right? It is not going to directly communicate, right? So it doesn't have a direct access with the ISA of the hardware. So through an operating system, it is going to access it. Why? In the sense it is housed within the operating system, right? So this is called as hosted virtual machine. So if you're going to launch a virtual machine on top of my what is it? Using an Oracle virtual box or a VMware kind of a thing. VMware also gives you virtual box. So coming to the hypervisor. Hypervisor is a simple user interface that needs some storage space for it to execute. So this exists as a thin layer of software. Okay, and it establishes the virtualization management layer on top of the hardware. Okay, it is like it is going to manage the hardware functions, right? So it acts as an operating system, this layer. So for provisioning VMs, okay, it needs what it needs: reverse drivers, software support. Okay, and many operating systems, which are all it won't directly work, right? So these hypervisors will work to launch those operating systems. And what happens is it enhances performance overheads, and so it allows multiple VMs to interact on the same platform. You see, you have hardware, you can have multiple virtual boxes on a laptop as well, and it can share the processor with the through the operating system which is running on the machine. So here, if you take hardware compatibility is one other challenge for hardware-based virtualization. And if you see, the virtualization interacts directly with the host hardware. That is your underlying hardware, and whatever drivers it requires. For example, you know about device drivers, right? For you to have the hardware driver, or you see, Dell will provide you all the drivers, right? Whichever is compatible for this laptop. Even you have your own laptop OSs. So for your device attached to your hardware, so whatever driver for the motherboard, for the random access memory, for the storage, yeah, so various vendors will give you all these spares, okay, so that you consolidate that and you give it as a laptop. Similarly, for a server also same way, the drivers should be supported and it should compatible with the hypervisor. So has hardware device drivers available to OS, okay, but such things may not be available to hypervisor platforms. Okay, if you see laptops, right, in this laptop you can install Linux operating system, let's say Red Hat or Ubuntu, okay, and you can also install Windows operating system. Those operating system will support whatever components have been installed in this machine. Let's say a graphics card or a sound card, yeah, or a display driver. So all these device drivers will be supported by the operating system. Okay? But few things will not be available in the hypervisor platforms. Okay. Moreover, host management and administration features may not contain as a range of advanced functions. Yeah, if you see, these things are mostly it will be there in the operating. So Hyper-V communicates with the underlying hardware mostly through vendor supplied drivers. So Hyper-V is one of the hypervisor from Microsoft. Now let's see the features of. So I'll go a little faster, okay, because a lot of topics to be covered. So a lot of features are there based on hardware-based virtualization. First is isolation. So hardware-based virtualization provides strong isolation for virtual machines. Okay, which means that any problem with one of the virtual machines will not affect the other virtual machine, which is running on the same physical host. Next is security. So hardware-based virtualization provides high level of security as these virtual machines are isolated from the host operating system and other virtual machines as well, which is running on the same host. Okay, so even if one machine is got infected, which will not affect the other machine. Next is performance. So this virtualization provides good performance as a hypervisor has direct access to the physical hardware. Okay, so which means that virtual machines can achieve close to native performance. Next is resource utilization. So here hardware-based virtualization allows flexible allocation of hardware resources such as memory, CPU, I/O, bandwidth to the virtual machines. Next is snapshot and migration. So if you have, we saw the part one is what the hardware based. Part one, that is the type one hypervisor is what is the hardware based virtualization. Okay, so hardware based virtualization allows creation of snapshots. Okay, which will help us to take backup and later use it for recovery purposes. And it also allows to do live migration. Let's say your VM is running on a physical host and you can directly lift and shift that VM from another host to a new host. And then this supports multiple operating systems. So, which allows consolidation of workloads on fewer virtual machines and reducing hardware and maintenance cost. Next is compatibility. So, hardware-based virtualization is compatible with most of the modern operating systems. We'll say like Windows, even Mac can also be virtualized, and you can integrate it with the existing IT infrastructure. So you'll see some of the advantages and disadvantages of the hardware-based virtualization. First is this reduces the maintenance overhead of para-virtualization. So as it reduces the modification of the guest operating system, let's say you have a OS running on a hardware, and on top of that you have installed the hypervisor. Okay, so those uh, those are overheads, right? You have a OS already running, and on top of that you are creating a VM, and it is again overhead. So that can be reduced when you use SPV. Okay? And it is again convenient to attain enhanced performance because you have direct control over the hardware. And if you see disadvantages of HVPs, so it requires explicit support on the host CPU, okay, which may not be available on these processes, let's say x86 and x86 64 supported processes. Next, a pure hardware-based virtualization approach. So including the entire unmodified guest OS. So it involves many VM drafts. Okay? So there will be rapid increase in CPU overhead. And this also limits, sometimes it limits scalability and efficiency of server consolidation. So this performance it can be mitigated by using para-virtualized drivers. Okay, so it is called as combination of what is that hardware and partial software included, so that it gets optimized. So if you see modified and unmodified guest OS is nothing but a hypervisor. Some places VM gets locked and will not be able to release those resources. Okay, this will cost what is that? It will cost the increase of CPU. Let's say two VMs are running on a physical host. Okay, on a using a hypervisor. So for this scalability only, what we do is we are going to use para virtual drivers. So let's see about hypervisor. So hypervisors is a software, okay, that enables virtualization, and it allows host machine to allocate resources to the destinations. Host machine is starting with the hardware. Okay, let's check the diagram. So now you can see from the bottom, you have the hardware, and top of that, you have the hypervisor. So hypervisor is ring -1, and ring 0, you have uh, the VM rated OS, let's say, the VM bus, and if you see the right hand side, you have the user mode, let's say, application of the ring. Okay, so if you see at the left hand side, you have Windows kernel and virtualization service provider, VSP. Yeah, and along with respect to device drivers. On top of that, you have parent partition, which takes care of the VMs when to create a VM. So these are the functions of the hypervisor. You can see at the left hand side, and right hand side, you have the actual VM. You have to see virtualization, serves consumer, Windows kernel, and top of that, it runs the application on top of the Windows. So now you can see the difference between the type 1 versus type 2 hypervisor. So first, or the physical hardware you can see at the bottom. And on top of that, you have the hypervisor. Hypervisor is like your VMware, vSphere, Citrix, Xen server, or your Microsoft Hyper-V. They are the most popular hypervisors in the market. And if you see at the right hand side, which is the type 2 hypervisor, and you could see you'll have most operating system, that it be Windows or Linux. And on top of that, you have the VMware workstation or the Oracle VirtualBox. On top of that, you'll run what is that? Your VMs through the para virtualization drivers, of course. Okay. Now let's discuss about virtualization hardware. So we see at least one CPU core per virtual machine. We even discussed this in the previous session, like how the cores will be spread across. So if you have three cores for high stress situations recommended. So what happens is like this device the actual cores in two or three, so that during virtualization only few cores will be allocated to a particular mission. Next is random access memory. There is no set amount for RAM. So if you see estimate minimum amount of RAM and you can upgrade based on your performance for a VM. And for networking, so networking has multiple network cards. You can attach those network cards to your VM and you can increase the throughput. So that is not applicable for your physical server communication. You have network cards by default. And you can also measure peak traffic amount. The last one is the network virtualization. Next is storage. Storage is one of the important part. Okay, so if you see local storage on servers is limited, you'll know that. Now, it allows 20% extra storage space for VM files and server snapshots. And storage networks, which are highly recommended for building data centers just with the cloud, they will use SAN or an NAS. Okay, so SAN is for storing large data transport, which is totally like it will have a fiber optic connectivities. For the NAS, it is for file-based data storage. You can see how a diagram like how it is. So you have physical server virtualization is done, and network how it is done. They create a mesh kind of a network architecture. If you say Hyper-V network virtualization, it runs on top of the physical network. So each virtual network operates as if it is running as a physical network. Next is the advantages of server virtualization. So you can reduce number of servers. It reduces TCO, total cost spent, and it improves availability and business continuity. And it increases efficiency for development and test environments. Okay, instead of having procuring more number of hardware and installing it for the development of test environment, you can have it launched. A VM can be launched and immediately you can close it once your test is done. Now let's see about the types of server virtualization. So server virtualization means partitioning of physical server into number of small virtual servers, each running. So from the first diagram we saw, right, the same thing, each running its own OS. So these operating system are known as the guest operating system. So these are running on another operating system, which is known as host operating system. So each guest is running, right? So guest running in this manner, and they were unaware of other guests running on the same host. That is what we saw, right, in the benefits. Okay, and different virtualization techniques are employed to achieve this transparency. Next is types of virtualization. First is hypervisor based. So the hypervisor is the layer which exists between the OS and the hardware. So it provides necessary services and features to run multiple operating system. And it also identifies traps and responds to privileged CP instruction. What is the meaning of trap is? Let's say you have an OS, right? You would have studied operating system. Yeah, I don't think have you guys studied any operating system paper in the previous semester? Operating system. So if you see in the operating system or even an architecture, computer architecture, computer organizational architecture. So you will have different call system calls. Even in your system programming, you would have studied about system calls, right? The system calls is what system related calls. Let's say you want to access a printer or you want to access some other devices, right, which is connected to your server. Okay. Those instructions are called as privileged CP instructions. And it has to handle those queues, right? Whenever there is a instruction you want to execute your software or your program on the CPU, At the same time, the another OS also wants to execute some data. Okay, how this it is managing all those requests. It is taken care by the hypervisor. Okay, so if you see the host operating system, it runs on top of the hypervisor to administer and manage the virtual machine. So every virtual machine will have a operating system. Next is para virtualization. So it is based on the hypervisor. Okay, so like emulation and traffic overhead. Okay, in software implemented virtualization, which handles this model. So here what happens is the guest OS will be modified and recompiled before installation into the virtual machine. So due to this modification, the performance is enhanced. Okay, so that the guest operating system communicates directly with the hypervisor and the emulation over is removed. Next is examples, like you will see Zen primarily uses. Zen is from Citrix, okay, para virtualization, where a customized Linux environment is used to support the administrative environment known as domain zero. So advantages of server virtualization, it is easier and it gives the enhanced performance and no emulation over this required. Okay, so next is limitations. So requires modification of the guest operating system. So you can see the diagram. So now you can see above the hypervisor, you have a VM administrative console, para virtualized VM, and one more para virtualization VM. So next is full virtualization. Full virtualization, it is similar to para virtualization and it can emulate the underlying hardware whenever necessary. And the hypervisor traps the machine operations used by the operating system to perform I/O. So usually hypervisor will take control over the OS. Like on top of that, it is running guest OS, right? So through that, whatever the request it comes, it takes and it modifies the system status based on that. So after trapping, these operations are emulated in software. Okay, and the status codes are written very much consistent with what the real hardware would deliver. Okay. So it is like instead of directly getting concurrence from the hardware, it takes control over it, like a virtualization infrastructure. So this is the only reason why an unmodified operating system is able to run on top of the hypervisor. So example is like your VMware ESX server used for this. It uses this method. So you can have a customized Linux version on a service console, and you can use it for operating system administrative operating system. But this is not as fast as parallel switch. So let's see a few advantages. No modification to the guest operating system is required. And then in full virtualization. And it is complex and slower due to emulation. And the installation of new disk device driver is also difficult. So you can see the hypervisor has full virtualization, which has path management and device emulation management. So next is hardware assisted virtualization. So it is similar to both full and para virtualization in terms of operation. Okay, so only thing is how it takes the hardware support. That is what we need to see. So here, if you see much of the hypervisors over it would be due to trapping and emulating IO. Okay, when they need to access IO, because they'll be giving controls to IO devices. Okay, let's say the input and output devices. So these status instruction executed within the guest OS is dealt by the hardware extensions of the x86 architecture. Let's say who are managing it, whether it is the hardware managers or it is the drivers who manages that. So if you see unmodified OS can be run as a hardware support for virtualization. So mostly it will get the request hardware request privileged and protected operations. Okay. So examples are AMD, B Pacifica, and Intel VT Vanderbilt. So they provide hardware support for virtualization. Next advantages here also no modification is required, and it is very less. It has hypervisor for it. The limitations hardware support is required. Next is your kernel level virtualization. So kernel, instead of using an hypervisor, you can run a separate version of X kernel, and you can see those VMs associated with them. Okay, which is called as the user space process of the physical host. So you can run easily. You can run multiple VMs on a single host, and the device driver communication is managed by the main Linux kernel and the virtual machine. And then processor support. So these process support required for virtualization is your Intel VT and AMD. Okay, it is like desktop based architecture. So Intel VT is virtual technology, and your AMD is AMD's virtualization. So slightly modified QEMU process is used to display and execution of the containers of the virtual machines running on top of the respective OS. So kernel level virtualization is a specialized form of server virtualization. So advantages of kernel level virtualization is there is no special administrative software is required because kernel itself will take care of all those things. And with very less overhead, and here also hardware support is required. We'll move on to the next one. So you can see the diagram. Okay. Next is system level or the OS virtualization. So this runs multiple but logical distinct environments on a single instance. Let's say OS kernel. Okay. So also called a shared kernel approach. So the virtual machines will share the common kernel of the host operating system. So based on the change root concept, so change root will start during the boot up, and the kernel uses root file system to load device drivers and perform other early stage system initialization tasks for those virtual machines. So it then switches to another root file system using change root command to mount. You want to mount a disk file system, okay, as a final root file system. So you can, it is like you'll have a common root and they'll have subsidiary roots for other VMs to get launched into a directory. So this change root mechanism, we call it as system level virtualization. So basically it enables system to start virtual servers on their own set of process that execute with their, it is like they need a space, right? So they will have their own file system and root directories from that change root. So main difference between system level and server virtualization is whether different operating system can be run on different virtual machines. So you see, if all virtual servers must share the same space or same copy of the operating system, it is the system level virtualization. So if different servers can have different operating system, it is called a server virtualization. So example like pre-VPS, your Linux vServer or the Open vServer. For example, you can have a system level virtualization where you can host only a single VM on top of whatever devices. Okay. So whereas in server virtualization, you can have multiple OS you can run on top of it. Because under that you will have the abstraction of hardware. So advantages is significantly it is lightweight than your complete machine. And you can host many more virtual servers. You can have enhanced security and isolation. So if you virtualize OS, okay, which usually has a little to no overhead, okay, mostly. And here also live migration is possible with OS virtualization. And it can also leverage dynamic containers using load balancing between nodes and clusters. So on OS virtualization, you'll have you can use a method called file level copy on write, okay, which will help us to take backups in an easier way and more efficient. Space efficiency can be managed. Even you can have a block level. You will usually have block level copy on write schemes. Here you have file level as well. Applications are like kernel or driver problems can take down all virtual machines. For example, the kernel is again, it is internal to OS, and if something goes wrong to the kernel, all your VMs will go down. So let's have a short break and we'll continue with this. Okay, guys, let's continue. Discussion. So the history and all cover later. Okay. So I'll share this presentation so that you can see. So virtual server, if you see, which came in 2005, and Hyper-V from Microsoft, which came in 2012. The Hyper-V architecture, which we saw just before in the other slides. So next is your hyper-converged infrastructure, where so this is a virtual machine monitor came in the year 2022, and so hyper-converged infrastructures are like server consolidation based on racks. Okay, so Windows Server clusters, you see, they introduced hyper-converged infrastructure in the year, so if you see 2021. Okay. So if you see, it runs most of the HCI infrastructure OS runs on top of the on-premise clusters with virtualized workloads. So if you see on an on-premise cluster, in the sense, a rack will have multiple servers, and those servers will be installed with your VMware or Citrix and hypervisor, and they will group all these hardware and consolidate them into a software-based uh, software-assisted data center or software-defined data center. Okay. Whereas if you see all your cloud comes under software SDDC, okay, software-defined data center, and they come under the converged infrastructure. So you can see Azure Stack, okay, which provides hypervisor. Okay, you can run virtual machines on top of the on-premise infra. So let's discuss about the virtualization software. So VMware, okay, it is one of the product, and which is also popular in line with virtualization software, and it is the first company here to utilize virtualization on x86 machines. Okay, so it runs Linux, Windows, and Mac. So vSphere, earlier they used to call it as ESXi, which is costly and has high overhead. And servers, they call it as VMware server, which is free and is not as powerful as the ESX or ESXi based VMs. And if you see introduction to virtualization and resource management in IaaS, infrastructure as a service. So a rise of resource overcommitment, if you see, it is the allocation of more virtual resources to a mission or a group of virtual machines, okay, than are physically present. If you see, we separate the cores. Let's say you have some 4 cores, but it will be virtualized as 8 cores. Okay, you give overcommitment. So resource overcommitment is the best use to make use of resource present in the virtualized cloud infrastructure. As I told you, right? Let's say I gave you a simple example where your 4-core processor uh, is converted or is assumed to be work as a 8-core processor. Okay, so you split your loads accordingly so that you share those core of processor cores. Just an example. Okay. So as you see, most of the application will never use all the resources allocated to them all the times. Okay. So if you see, if you run a server and only one application you'll be running at a time, a few applications you'll be running at the given point of time. Whereas, what happens to those unallocated or unused space or the process? Okay. So this is it is like the resources provided by the provider will remain idle without overcommitment. So resource management is an indispensable way to make use of underlying hardware of the cloud effectively. Okay, so here a resource manager who takes care of all those physical resource allocation to those virtual machines. Okay, on a cluster of nodes. If you see, it is not a single node. A node is nothing but a rack. Okay, a rack will have 5 to 10 servers. Okay, and those single rack will be called as a node. Okay, So that node will give consolidation of both what is that, the server, the CPU, memory, and storage, which is there in that server. Okay. So the resource management systems have differing purposes based on the requirements. Okay. So if you see virtual machine reduces operational cost, but if you see it can be accomplished through overcommitment of resources. So a few issues we have, you see, with respect to resource overcommitment. Okay, it has few challenges like as a removal of hotspot, and you have a dilemma where to schedule new incoming VMs to reduce the chances of the hotspot. So you can see a diagram where how resource management is taken care. So resource modeling, resource allocation, and reconfiguring based on customer need, and resource monitoring. So how many you have allocated and how many is free, so that you can allocate that to the end user, as well as if you want to add some more resources, how you will keep the nodes ready so that you can attach the nodes to your data center and extend your large pool of resources. So mitigating change of hotspot. Okay, so if you do live migration and memory ballooning of VM, help in minimizing those hotspots. And ballooning can be used if a VM is low on memory. Okay, so to take away some more memory from one of the guests. Okay, if let's say on a server you're running three VMs and one VM is needs some more memory. Okay, where the other two VMs are idle. Okay, you can share those memory with them. So if none of the guests have enough free memory, then most of the time the host is overloaded. Okay. In that case, a guest has to be migrated from the current host to a different host. Okay, so it will be automatically shifted if it is. So it is based on the allocation of the SKU, okay, on the particular cloud. So how does the pass next is how does pass compare to internally hosted development environments? Okay, so pass can be accessed over any internet connection. Okay, and you can build an entire application in a web browser. So where your development environment is not hosted locally because it is hosted on the cloud. So developers can work with their application anywhere in the world. So this enables teams that can spread across geographical locations to collaborate, and they can work on a single project. So here the major part is the developers have less control over the development environment, okay, which is the you can say it is a less overhead for them. So all these red ones are managed by the infrastructure, that is your service provider. So what is included in PaaS? If you see, it includes major offerings like development tools, middleware, your OS, database, and infra. So different vendors may include other services as well, but these are the core PaaS services. So development tools like variety of tools which with respect to software development. Example, you could see Google has its own software development kit. Using that, you can use the Python compiler, the integrated development environment, you can directly write your code and host an application there itself. You can test it on a web browser. Similarly, a lot of tools are available with a lot of frameworks. And if it comes to middleware, if you see platforms offer various services with respect to middlewares, like you have uh, examples like you allow certain software to integrate your database with your application. Okay. So operating system, you all know pretty well. So PaaS vendors will provide and maintain the OS as well. Okay, as the developer works on the application, which is going to run on top of the operating system, and databases like the PaaS provides, and also it administers the database. Okay, as a software, you can directly launch a sized database and you can use it. So infrastructure is again the other layer where all these higher level products, which you say like OS or the development software, everything is managed by the infrastructure, and this infrastructure is also managed by the PaaS providers. So PaaS providers like, let's say, Azure will take care of the managing the server storage, the physical data center, any purchases with respect to the database, licenses, all these things will be taken care of. So why do developers use PaaS? So faster time to market, and we're running time. So stop it here. There are some more slides. So this demo we'll do it next week. Okay. So we are going to use type 2 type 2 hypervisor. You can also install, you can just take a note of it. You have to download this version. Okay. So Oracle VirtualBox, you can download it from the internet. So I'll show you website. If you're using a personal laptop, you can do it pretty well. So, share it again. So Oracle. So, so, so it's good. Quickly you can install the and our VMware workstation or a virtual box. Also, so, 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 now they've changed the name of Sims. Now they've changed it to VMware workstation. It's free only. Yeah, now it should work. Go for this. So yeah, I already have it. showing some more installed. They already have a virtual box. Let's see the version 7.0. Okay. So this is how it looks. Yeah. Already loaded a Ubuntu VM on top of it. Okay, this one I'll tell you. So if you see, this is a hypervisor, yeah, which is running on my type 2 hypervisor. So if you just click start, your whatever. So this is settings. So see, I've launched Ubuntu or the 64 So you have to install this. Okay, I'll install it and allocated memory and all. Just click start so that power up. See, this is how even will get launched. So meanwhile, I've scheduled a quiz for you guys. Okay. Yeah, it's getting launched. So you need to download this image from internet from what is that from Ubuntu website also. Download the latest image. And I used this virtual machine for taking system programming class. This part. Yeah. Or repair that. So just keeping this virtual box in personal laptop. So internally, I will use those terminal routes so to execute commands on Linux. Similarly, in cloud, we'll work on Docker's, yeah, Docker infrastructure where we need a Linux VM. You can use Ubuntu VM and you can launch a Docker container, such things. And I'll also teach you that with the upcoming sessions, which will also come as a practical class for you. It's taking a little bit time. So you can take the quiz now. So, answer. So even if you have a Windows image also, you can run a Windows, you can launch a Windows OS on the box. Take the time. You can take the quiz and you can leave for the day.